Shall we start this event now? 6 p.m.
Yeah, sure. Let's get started. Good evening, everyone. For those of you who are joining us for the second time, thanks for joining in again. And for those of you who are joining the first time, so this is the Python Sprint 2, which is going to cover the basics of Python. And this event is organized by Codecademy along with FOSS Club. And a quick introduction about the core members. I'm Pranav. I'm a third year data science student at Jain University. And I'm part of the ANOVA club and the GDSC club along with the Codecademy club. So I'm currently exploring different domains like data science, machine learning, deep learning, AI, and cloud computing. So we have with us Ashwin Bharat, who is the chapter lead at Codecademy Jain University. Maybe Ashwin, you could introduce yourself.
Sure. So, hello everyone. Once again, I welcome you all for this follow-up event from Python Sprint. So myself, Ashwin Bharat, I'm from Jain University, currently pursuing my final year in software engineering. I'm specializing in web development. I have built full-stack web applications on MERN stack, and I've also explored other databases from the backend and built several REST APIs. So I welcome you all. I hope this event will be helpful for you in the future, right? So we also have follow-up events for this Python sprint. So stay tuned, and once again, thanks for joining.
Thank you so much, Ashwin. And we also have with us Sharanya, who is also the co-organizer for this event. Sharanya?
Yeah. Hi guys, so this is Sharanya from Data Science third year at Jain University. I'm a data science head for this Codecademy chapter and also core member for the ANOVA club. I'm currently pursuing machine learning and AI fields. So thank you for joining the event. We have furthermore events to come in this field.
So guys, for those of you who are confused about this, so this is the Python Sprint 2, which is a part of covering the basics of Python. We'll also be extending this to various other domains as well. So just keep attending all these events and stay tuned for much more learning. And so today's event will be hosted by Kirti Chelluri. She's also a third year student from data science in Jain University. And she's also the head of technical content writing at GDSC and also an ANOVA core member. So she's also exploring different domains like data science, ML, DL, AI, and cloud computing technologies. So I guess I'll hand over the session to Kirti now, and all the best, guys. Either you can unmute or you can just drop your questions in the chat box if you have any. We'll just keep answering them. Over to Kirti.
Hi guys, thank you for attending this event. So as of now, thank you Pranav. It's a very good introduction about me. So there is nothing much. I think we could step into this event further. Actually, before stepping into this event, I need to solve some doubts in which you people have asked in the sprint session 1. So for those people who are not unable to use Colab, you can use Jupyter Notebook, you can use NetBeans, whichever console that supports Python, you can use any of that. For data science people, I would recommend Jupyter Notebook because it's very good for visualization. And for deep learning packages, you can go for Google Colab to run various packages. And also, if you want the ipynb file of session 1, my co-organizers will drop it in the chat box. You can go through it. Now I think we can start the session. Yeah, I think my screen is visible to you, right?
Yes, Kirti, yes.
So today we're gonna learn about Python basic operators. So operators play a very important role in programming, but it doesn't have the same relationship with every programming language. With Python, it's somewhat different compared to many other languages. So before getting into what type of operators we have in Python, let us know what's the meaning of operator and how it plays a very important role. So generally, operators provide a vital role in programming, and it is the combination of values as well as other identifiers from expressions and statements, which is also known as essential building block of Python programming. So operators are not only they can be used with symbols to perform various mathematical as well as logical manipulations. So we have operands along with operators. Operands are nothing but they are the values or variables with which operator is applied to. For example, let us take a scenario. We have here the example as you can see on the screen, 6 plus 2 equal to 8. Here we can say that plus symbol is an operator and 6 and 2 are the two operands which gives us a result 8. Here we are just using a single operator to manipulate the whole equation. So let us now know about different types of operators we have. So we have arithmetic operators in Python as well as assignment operators, comparison operators, logical operators, identity operators, membership operators, and bitwise operators. These are the main operators that we're going to use in Python. And not only in Python, before you start any programming language, these are the important operators you should know about. So first, let us go with the arithmetic operator. So arithmetic operator they're pretty much similar that we have learned from our 6th standard, from our secondary education. You know about addition, right? Subtraction, multiplication, division. We have modulus, which returns us the remainder, and we have exponential, and we have a floor division. Floor division is somewhat different from our secondary education, and it plays a different role, and it has a different relationship in Python language. So in coding purpose, you can write it as x plus y. You can take any two variables and apply the operator, arithmetic operator, to those two variables. Now let us see arithmetic operators in Jupyter Notebook. You will have a clear idea about it. So I can share you the screen. Yeah. As you can see, I have declared two variables here, x and y. And I have associated with the values 10 with an operator equal to and y equal to 2. So now I'm going to perform addition for these two. Since Python is dynamically typed language, we do not need to declare the data type of a particular variable. It assigns itself. That is the advantage we have with Python as compared to many other languages. So just I'll run this cell. You can see it gives the direct output of adding x plus y. Then we have subtraction. It gives you 8. Then we have multiplication. It gives you 20. Then we have division as normal max we do. It gives you. Always remember in Python, the division will be in the float value. The remainder we get is always represented in float value when you use division. So now we will move into another operator, that is modular operator under arithmetic. So modular operator is nothing but it gives you the remainder. Whenever the divisor is positive, it's a simple normal regular division, what remainder you get. But you need to take care when the divisor is negative, because when the divisor is negative, we apply floor in Python. Only in Python we apply floor. For people who don't know about floor, I'll explain you, no worries. As you can see, for doing modular division in Python, we use the formula, which is the backend formula, that is R equal to A minus n into floor of A by n. So here R is the remainder, A is the dividend, and n is the divisor. So what is floor? Floor is nothing but it is an equation which is used to do floor division. When you keep positive numbers within the floor division will return the same result as truncated division. For people who doesn't know about truncated division, it is nothing but we use in different we use the truncated division in Java, JavaScript, C++, all follow the truncated division. Here in Python we follow the floor. The main difference between truncation and floor is nothing but, for example, here we have, just a minute. Okay, fine. Yep. So here we have floor, as you can see. When you apply floor for 8 and 3, here where R is the result, what we're gonna get. In place of A, we're gonna take 8, and in place of N, we're gonna take -3. So the formula for it is, after substituting it in the formula, 8 minus of -3 into floor of 8 divided by -3. where the next step will be r equal to 8 minus of minus 3 into floor of, where 8 divided by minus 3 is minus 2.666. So when there is a negative number in the induced in the floor, we round that particular value away from the zero. So when minus 2.66 is rounded away from the zero, the value will be minus 3. So r is equal to 8 minus of minus 3 into minus 3. So the final result will be r equal to 8 minus 9. That is r equal to minus 1. That's it. So this is the type of floor division we follow in Python. But whereas in other languages like C, C++, JavaScript, we follow truncation. Truncation is nothing but when you same formula is replaced with truncation instead of floor. That is r equal to 8 minus of minus 3 into truncation of 8 divided by minus 3. That is 8 divided by minus 3 is nothing but minus 2.666, as you can see. This minus 2.66 is rounded towards the zero, which is opposite of the floor division. In floor, we round it away from the zero. In truncation, we round it towards the zero. So the final result will be r equal to 2. So this is the backend that is built in the Python. That is the main formula behind modulus and floor division. So let us check. Now, as we have seen, we have taken values for x and y. That is x equal to 10 and y equal to 2. Now I'm going to do the modulus division for x and y. As you can see, the remainder is 0. And I'm taking with a negative number now. For negative, I'm going to do the modulus. It is 2. Now, 10 modulus of minus 6, it's minus 2. This can be solved by substituting them in the above formula as I have shown you. That is r equal to a minus n into floor of a by n. So now we directly do the floor division without inserting any modulus. That is, as you can see, the double slash in Python represents the floor division between two variables. It's 5. Now we have taken this as minus y. Let us see. It's minus 5. Now I'm taking directly numericals instead of variables. So it's minus 7. You can substitute it in the above given formula and you can recheck them manually. So this is all about arithmetic operators. Now I'll move on into assignment operators we have. So here we have, these are the assignment operators. Just have a look at them. Assignment operators are nothing but they are used to assign values to the variables. For example, when you are declaring any variable, there should be some operator in order to assign a value to that. So here we have different type of assignment operators. Don't confuse by seeing this equation. For example, we have x plus equal to 3. It is same as x equal to x plus 3. And similarly, we have x exponential equal to 3. It is nothing but x equal to x of exponential 3. And so on. Here, as you can see, this is and equal to or equal to XOR equal to right shift equal to left shift equal to. So I'll explain you about these operators in detail while we move into the Jupyter notebook. Just a minute. So here we have the assignment operators. So I'm declaring a variable x and assigned a value 5 using the operator equal to. Now I'm going to print x. So it's 5. Now I'm using plus equal to assignment operator to my variable. As usual, it prints 8. That is nothing but 5 plus 3 equal to 8. Now I'm using minus equal to 3. That is nothing but 5 minus 3 equal to 2. And similarly, we have exponential, that is 15. Sorry, the above one is the multiplication. And now we have the division. That's 5.0. Now we have modulus division. That is 2.0. And now we have the floor division. That is 0.0. Now I have taken here another variable y. Y equal to 15 and I have applied the exponential assignment operator to it. That is nothing but y power 3. So I'm going to 15 power 3 is nothing but 3,375. So these are some of the assignment operators. Now I'll go into one more assignment operator, that is and equal to. For people who doesn't know how and equal to works, it's nothing but, for example, if you're familiar with logic gates, I think you have a pretty much idea about this and, or, and XOR. Okay, fine. We'll just have a recap about it. For example, I'm taking here two numbers, that is 1 and 1. When I'm applying AND operator between 1 and 1, it gives you 1. 1 is declared as true here and 0 is declared as false. For example, I'm using AND operator between 1 and 0. It will give me a result of 0, which is false. And similarly for 0, 1 and 0, 0. So let us see how this works. So this is the basic rule that applies anywhere when you're using AND operator between any two numbers or any two variables and anything. So for example, I take 2 and 3. I have written 2 in the binary format, which is 1, 0. And 3 I have written in the binary format as 1, 1. So now I'm going to apply AND operator between 2 and 3. So 0 and 1 returns you 0. 1 and 1, it returns you 1. This 1, 0, it is the binary format which represents the decimal format of 2. I think I'm clear here. So now just declare a variable z and I have assigned a value 2. Now I'm using assignment operator, which is and equal to, and I'm printing my variable z. It gives you 2. It's nothing but the main manual work behind this code is the above one, which I have discussed here, 2 and 3. It can be implemented in Python like this. Now let us go to OR operator. So here in OR, similarly as n, we take 1 and 0. But in OR, we apply OR operator between 1 or 1. That is 1. It gives you true. 1 or 0, it gives you 1. That is true. And 0 or 1 is true. 0 or 0 is false. Now let us see how we can apply OR operator between numericals. I'm taking 2 and 3. So 2 is written as 1, 0 in the binary format and 3 is written as 1, 1 in the binary format. So now I'm going to apply OR operator between 2 and 3. That is 0 or 1 gives you 1. 1 or 0 gives you 1. 1, 1 is the binary representation of decimal 3. Now the similar can be done using the Python code. Now I'll run the cell. As you can see, it gives you the result 3. That's about OR operator. Now we'll move on to XOR operator. So in XOR operator, you take 1 and 1 and the 1 XOR 1, the result is 0, which is false. And similarly, 1 XOR 0, the result is 1, which is true. 0 XOR 1, the result is 1, which is true. 0 XOR 0, the result is 0, which is false. Now, the symbol you can see here, this is the XOR symbol which we represent. So 2 XOR 3, 2 is represented in the binary format as well as 3 is represented in the binary format. Now 0 XOR 1 is 1, 1 XOR 1 is 0. It gives you 1 as the decimal. So a similar work can be implemented by using the Python code. That is 0. Now we'll move into left shift and right shift. So before X, right shift n. X is nothing but X is nothing but it is the number, and n is nothing but it is the number of digits to be shifted. So always remember that when you are using a left shift or a right shift operator between the variables, make sure that your decimal is represented in 8 bits. Represent your decimal in 8 bits. So for example, here I'm representing my decimal 4 in 8-bit binary format. And now I'm applying it a left shift operator, that is 2. That is number of digits to be shifted is by 2. So as you can see, originally the 4 is written here in 8-bit format. When you're shifting using the left shift, the result will be 0, 0, 1 and 0, 0, 0. Nothing but the 1 is shifted 2 places towards the left. And this binary format is nothing but it is equal to 16 in decimal. Now I'll move on to right shift 2. Here nothing but the 1 is shifted 2 places towards the right, as you can see here. And this binary representation represents 1 in the decimal format. So the same manual work can be implemented easily in Python by just assigning an operator, that is right shift equal to, you can see here, it's 1. And similarly as well as left shift, it's 4. That's pretty much about assignment operators. Yeah. now we will move on to comparison operators. So these comparison operators are nothing but when you're declaring two values or two variables, these comparison operators helps you to compare those two values or those two variables. We have equal, we have not equal to, we have greater than, less than, we have greater than or equal to, and less than or equal to. So let us see how this works in Python code. This is how come. Here I have taken another two variables, E and F. And for E, I have assigned a value 6. And for F, I have assigned a value 7. So now I'm checking whether E is equal to F. Guys, don't confuse between single equal to and double equal to. Single equal to is used to assign a value to that variable, whereas double equal to is used to compare the value between two variables. Okay, just shift enter. It's false. Always remember, comparison operator will return you result in the terms of Boolean expression. It will not return you values in numerical format. So when you are comparing E and F, as 6 is not equal to 7, it returned as false. Now I am checking where E is not equal to F. It's true. As we know that 6 is not equal to 7. Now E greater than F. It's false. Obviously 6 is not greater than 7. Now we are checking E less than F. Yes, it is true. 6 is less than 7. Now I'm checking here E greater than or equal to F. I think concentrate on my pronunciation. That is greater than or equal to. You can see that we are using or between greater than and equal to. As I have said, when you are using an or operator, if any one of the primary conditions satisfies, it returns you the result as true. For example, E greater than or equal to F. It returns you false because E means 6. 6 is obviously not greater than 7, and also 6 is not equal to 7, in which both the conditions are not satisfied, so it will return you false. Now I am checking E less than or equal to F. It will return you true because one condition is satisfied in this particular cell. That is E less than F. Yes, obviously 6 is less than 7. It's satisfied. That's the reason it gave you the Boolean expression as true. Now we will move on to the logical operators. So here we have the logical operators. Logical operators are nothing but they are pretty much useful when you are declaring the conditional statements. They are used to combine the conditional statements and sometimes as well as to compare them. So as you can see, we have three types of logical operators: and, or, and not. So what does this AND operator do is it will return true if the given both statements are true. And OR operator, it will return true if either one of the statement is true. And NOT operator will reverse the result. That is, if we are getting the result as false, it will reverse it and will give the result as true. So let us see how X or Y works. For example, here I'm declaring X and Y as two variables. If X is true, then it will return the output as true. But if it is false, it will check for condition Y. If Y is true, then it will give you the true output. If it is false, it will give you the false output. Let us see how it works in the Jupyter notebook. See this here, yeah, we are having logical operators. So we are checking E less than 3 and E greater than 4. Let us check what it will return false because obviously 6 is not less than 3 and 6 is also not it is since we are using AND, here it's compulsory that the two conditions should satisfy. If either two conditions are satisfied, then it will return you the result as true. If either one of it fails, it will return the result as false. Now we are using the OR operation. It is true because one condition is satisfied, that is E greater than 4. Now I am using the two operators of logical, that is NOT and which will give you the opposite result. That is true because as you can see in the upper cell, we have taken E less than 3 and E greater than 4, which gave us the result false. And for this false, we are applying the NOT logical operator, that is which gives you the opposite of false, that is true. So now let's move on to the identity operators. So identity operators are also used to compare the object, but they are not equal. That is, if they are actually with the same object with the same memory location, or you are using identity operators when they are present in the same memory location. For example, you have two identity operators in Python, that is and is not. For example, we take is, it will return as true if both the variables are of the same object. For example, is not will return true if both the variables are not present in the same object. In code, we'll declare two variables x and y, and we use the operator in between them. That is, x is y, and another operator, x is not y, between two variables. So let us move on to the Jupyter notebook and have a quick recap. So here I'm using identity operator. I'm applying is identity operator between two variables e and f. It is false because e and f are declared separately and they are not present in the same object. And e is not f, it will return true. Similar condition where e is not present in the same object. Now we'll move on to membership operators. So membership operators are used to test if a sequence is present in an object. For example, in the previous identity operators, we have checked whether the given variables are present in the same object, but here we are testing a sequence which is present in the same object or not. So we have two membership operators, that is in and not in. In always returns true if a particular sequence you are searching for is present in the object. And not in will always return true if your particular sequence you want or what you're searching for is not present in an object. In core format, we write it as x in y, where x and y are variables and in is the operator, and x not in y, where x and y are variables and not in is the operator. So as you can see, here I have modified it. I have used if-else loop. So let us see how membership operator works. So I have declared two variables x and y, and I have initiated the value x equal to 24 and y equal to 20. And now I am preparing a list which consists of 10, 20, 30, 40, 50 numericals. For those people who doesn't know about list is nothing but it is a data type in a Python which we represent using a square brackets and the value separated using commas. It can be homogeneous and heterogeneous. You can insert any type of values into the list. Okay. So I'm applying if condition here. I'm using not in membership operator. That is, if x not in list, then it will print as x is not present in the given list. If x is not present in the given list, then it moves to the else operator. That is, if x is present in the given list, then it prints as x is present in the given list. Now, similarly, I'm using if-else operator for y variable. For example, I'm using here in operator, in membership operator. So if y is present in a given list, then it will print as y is present in a given list. Otherwise, it will move to the else statement and print it as y is not present in the given list. As you can see, it gives, since 24 is not present in the given list, it is represented as not present in given list. And for y is present in the given list, it gives you that y is present in the given list. Now we'll move on to the bitwise operators. So these are the bitwise operators. Bitwise operators are similar that we have used previously in the assignment operators. I have taught you like and, that is nothing but it sets each bit to 1 if the both bits you have taken are 1. And similarly, or if either one of the bit you have taken is equal to 1, it returns you the result 1 by setting each bit to 1. And similarly, we have XOR, we have negation or not. Not is also called as a negation. It's nothing but it inverts all the bits. For example, let us take you have a binary format of 0, 0, 1. It will invert the bits as 0 to 1 and 1 to 0. That is 0, 0, 1 is nothing but 1, 1, 0 when you apply the negation to it. So, and similarly, we have 0 fill left shift, which is similar to the left shift we have used in the assignment operator previously. And we have a signed right shift, which is similar to the assignment operator, which we have used. So they are basically, bitwise operators are basically used to compare binary numbers. So when you're dealing with binary numbers, it's very important to know about the bitwise operators. So I'll move into the Jupyter notebook. Yeah, these are the bitwise operators. I have taken two variables here, A and B, and I have assigned the values 10 for A and 4 for B. And now I applied each bitwise operator between them. As you can see, as I have previously discussed in the assignment operators, here you can find how AND operator works, how OR operator works, how XOR operator works, and how the left shift and right shift works, which is pretty much similar to the bitwise operators now we have used here. So I'm going to run this. As you can see, you have the values down. That's it. So after learning about the basic operators in Python, it's important to know when you have given a particular equation with multiple operators, it's important for you people to know which operator should you solve first. For that reason, we have given you a table here. These are the Python operator present. As you can see, we have different types of operators here. Each operator has a specific line to it. For example, the highest precedence you have is for exponential, and from exponential you go to the lowest, that is OR. Boolean OR has the least precedence. So depending on this table, you need to solve your equations. You cannot solve like you cannot use not first and then and. It totally depends on the precedence. Yep. That's it about Python operators. Thank you. Now I hand over this session to Sharanya.
That was a nice session, Kirti. So guys, we'll continue this session with a Kahoot game. So I'll share you the link so that you guys can join now. 1 second. If you guys have any doubts, you can put it in the chat session, then we'll answer all of your doubts.
Sharanya, I think you can start the Kahoot session. Meanwhile, they'll post the doubts. Yeah.
So guys, this is the game pin. So make sure you guys join now.
Guys, no need to worry. These are just to test your skills or how much you have gained the knowledge so that you can prepare yourself according to that. And guys, make sure that you practice the ipynb files which we are sharing in the chat box, so that practice is very important regarding coding. Guys, we'll wait for another 2 minutes and we're going to start the Kahoot session. If anyone is there yet to join, please join. Make it fast.
Okay, guys, then let's start the game.
I think next question. We have Coda 1, 2, 3 at the first position, Akhil at second, Satvika at third. Next. Guys, please check the question carefully. You have only 10 seconds to answer this. Just make sure you keep the right answer. Yep. Next. We have Coda 1, 2, 3 again in the lead position and we have Jet at the second position. Right. Thank you. Next question. Next. We have Satvika in the second position and Om at the third. Next. We have Satvika in the lead position. Good. Next. Good. Home in the first place. Okay, next. Shanya, can you zoom the question? I think so. This people. We have Satvika in the leading position. Next. Guys, hold on. Last 4 questions. You can get through it. Stargazer. Okay, next. We have Om again in the first place. Next. And congratulations, all of you 3. Om, Satvika, and Stargazer, whoever it is, can you please respond to me in the chat box? How was the session today? And also remaining people. Thank you, Om Jain. Wow. Thank you, Sujay. Thank you, Ganesh. Now I'll hand on to our chapter lead, Ashwin Bharat.
Yeah, thank you, Kirti and Pranav, as well as Sharanya, for this amazing event. I think both the event as well as the game was fun, right? And I can see people are very, very much interested in this event as well. They have seen, they posted, it is very interesting, quite informative. So, like, we'll also be conducting other events, guys, as a follow-up set of events, okay, where Kirti, Sharanya, as well as Pranav, they'll be in the future moving towards data science track, where they'll be covering a lot of more libraries that are present in Python as well. And I'll also be inviting other guest lecturers from the Code Academy community, right, where there are like a lot of chapters in which they are interested to come over here and teach you other topics. Okay, so this has been great. So I think let's wrap up this event for now, right?